Once you are familiar with the basic notations of BPMN, it's time to look into the more advanced notations. We will look into the advanced notations for activities, and we will look into the advanced notations for events, and then we will also consider some modeling alternatives where you can use similar modeling constructs to model something, and you need to make a choice about what is the best representation. So let's start in this part of the presentation with the activities. First, we look at when activities exactly start and end. So the idea is that when you have two activities in sequence, like here you have task 1 followed by task 2, as soon as the first activity is finished, so task 1 is finished, then task 2 will start automatically and immediately. When task 2 is an automated service, it means that, since we assume that the computer is always available, it will also be automatically and immediately executed. On the other hand, when the service provider is a human person, you have a user task or a manual task, then the task becomes available on the work list, on the to-do list of that person. It might also be notified to the user by email, but it doesn't mean that the user will immediately start working on that task. So it means that then the task stays for a while on the to-do list and later on it is performed. Now, even though the task stays for a while on the to-do list, we assume that the task has started. So here you see, for example, a little example taken from my work processes. You see I receive an email about my credit card. I will receive it at a particular time. It means that if I go into my application, my ERP application, I will see that in my inbox there is indeed some form that needs to be completed and sent to the financial department. But I might postpone handling that form for a while. In that case, handling this credit card notice might take like 2 months, 3 months. I will actually take only a few minutes to complete the form, but by the fact that I have been waiting to do so, the whole duration of the task is to be considered as, say, for example, 2 months. So if we look at another example, suppose that at 11:55 I tell my daughter to empty the dishwasher. It means that at that point in time, the task becomes available to her and is on her to-do list. She doesn't empty the dishwasher immediately. She first finishes reading her book chapter and only starts emptying the dishwasher at 12:10. And she finishes by 12:15. How long did the task empty the dishwasher take? Well, you could say between 12:10 and 12:15 it's 5 minutes. That's the time she needed to actually work on that task, but the task was already available to her at 11:55. So in a BPMN reasoning, the duration of the task is 20 minutes, 15 of which are waiting time from my perspective, and only 5 minutes are the actual work that has been done to empty the dishwasher. In terms of completing task, the thing that completes a task is the thing that triggers a flow out of an activity. So it means that as soon as a task is finished, the flow out of the activity is triggered and the next tasks or gateways or events, whatever, will be started. A subprocess is completed when all its parallel paths have reached an end. We'll come back to that one later on. That's the normal completion. You can also have the abnormal completion of a task. So it means that the task can be interrupted by an activity, or a subprocess can also be interrupted by various exceptional conditions. These exceptional conditions need to be modeled explicitly. It's always like that the internal state of an activity is invisible to the model reader, so you don't know at what stage a particular activity is. So you will use an event attached to the boundary of a task or a subprocess to model the abnormal completion. Here's an example here with a task 3, and then you see on the border of the task 3 you see a clock. That's a timer that might interrupt task 3 if it doesn't finish in time. If it doesn't finish in time, it means that the exception flow is followed. That means the arrow that is attached to this timer event. In case of the normal completion, it's the arrow at the top, so the one that follows, that goes in the normal way out of the task. So it is like a choice between either normal completion or abnormal completion. What you need to keep in mind is that events and gateways have no performance, so these are control logic elements. They are instantaneous, so they start immediately and they complete immediately, so they have no duration. Let's now look at the different activity types. First of all, we need to make a distinction between the simple task and the complex task. The complex task has a little cross at the bottom of it, and it's like a box that you can open. So if you click on the little cross, it will open up, and inside the box you will find a new process. For all the simple tasks, you can also give a certain label according to the nature of that task. First, we make a distinction between sending and receiving messages. A send task has a black envelope, and a receive task, where you receive a message, has a white envelope. Then you can also make a distinction whether you're dealing with human or automated performance. A service task is a task that is performed by an application, and so it is an automated task. A user task is a task that is performed by a human being that will use an application or make use of the business process engine. A manual task is also performed by a human person, but it is entirely manual, so there is no application support for it. A script task is also an automated task, but in this case the script is executed by the business process engine and not by an application. And then finally we have the business rule task, where some rules are checked by a rule engine. Let's now dig a little bit deeper into the subprocesses. Subprocesses are something that you can use if you want to visualize the end-to-end process. The end-to-end process might be way too long to fit on a single page. So what you can do then is to make compartments in that global and entire end-to-end process, and make some kind of high-level abstraction where you can view a number of subprocesses that you can expand later on. So it allows you to do top-down modeling, where you have coarse-grained subprocesses at the top, and then you can move down into the decomposition hierarchy and have more fine-grained defined processes at the bottom of your hierarchy. It's also used to clarify governance boundaries, because it is an entity, a subprocess is an entity, and you can put that within one unit of governance. And finally, we will see that we'll also use that to delimit the scope for event handling, especially for interrupting events. So here you see two examples of subprocesses. At the top, you have a subprocess that consists of two activities. So taking a break consists of two activities: read a book and work in a garden. A subprocess can have an explicit start and end event. Here it doesn't. It means that as soon as a subprocess is activated, every activity that has no incoming flow is activated as well. So it means that as soon as the subprocess take a break is activated, both read book and work in garden are activated. These activities can start. So that would be the same as a parallel split. When will the process end, the subprocess end? Well, it ends as soon as all the flows that are active in the subprocess end. In this case, there are two flows. There is read book and work in garden. When they are both finished, then the subprocess is finished as well. So this would be the equivalent of a parallel split to read book and work in garden, and then a parallel join with an end event. At the bottom, we see that the subprocess has received a tilde mark. A tilde stands for an ad hoc subprocess, and this means that every activity that is embedded in that subprocess can start, and it can start any number of time. So taking a break now means that I can read not only one book, but I could also decide to read 2 books or 3 books. I can work in the garden once, 2, twice, so there is not a fixed number of times each activity can be done. You can do each activity an arbitrary number of times. A second specific type of subprocess is the call activity. The call activity is used when you want to make your subprocess reusable, or you want to define it as some global task or global subprocess that is known across all the processes. In this case, you draw the subprocess with a thick border, and we consider it as an independent subprocess. Independent as opposed to the subprocess that is embedded in and only known in the encompassing superprocess. So if you look at the drawing, you see a subprocess for providing coffee for a meeting. If you draw it with a thin line, like on the left, then you will draw it inside some global superprocess, and it will only be known into that superprocess. If you draw it like on the right with a thick line, then this provide coffee for a meeting can be used in any process because it's a global subprocess, it's a call activity, so you can call it from any other process. The third type of subprocess is the event subprocess. The event subprocess is a process that can be started at any point in the global process. It is not part of the normal flow of its parent process, so it means there is no incoming arrow from the parent process into the subprocess, and there is also no outgoing sequence flow from the subprocess into the parent process. This means that in order to be able to start, a subprocess needs its own start event with a trigger. And each time that start event is triggered, while the parent process is active, then the event subprocess will start. So this also means that this start event may eventually not occur during the parent process, or it may occur several times while the parent process is ongoing. Moreover, the start event can be interrupting or non-interrupting. So let's look at an example. Assume that the professor's daily routine consists of a process with 3 tasks. First, prepare the class, then review the research of PhD students, and then keep up with scientific literature. During this process of 3 tasks, 2 activities can happen. The first one is fire alarm. This has a normal start event, which means that it will have an interrupting nature. So it will interrupt the activity the professor is busy with at that point in time. So it can interrupt prepare class, or if the professor is already reviewing the research of a PhD student, then it will interrupt that activity, or if the professor is busy with keeping up with scientific literature, it will interrupt that activity. And then when the fire alarm goes off, the professor will leave the building, and this terminates the entire process. So the professor will not go back to preparing the class, reviewing the research, or keeping up with scientific literature. On the other hand, the activity hydrate is an event subprocess where the start event has a dashed line. So this is the equivalent of a non-interrupting event. So it means that drink water will happen during prepare class if the professor feels thirsty while preparing the class, or it will happen during review research of PhD student if feel thirsty happens during the execution of that task, or it will happen during keeping up with scientific literature if feel thirsty happens during that task. Feeling thirsty can also happen several times because it's non-interrupting, so the process will go on, and the start event can occur several times. We can also indicate that activities have to be repeated. And there are 2 ways we deal with repetition. First, we have the loop activity, which would be the equivalent of a do-while statement in programming language. So it means that you repeat it sequentially and you check always a condition to decide whether or not you're going to continue and repeat once more. On the other hand, you also have the multi-instance activity, which is the equivalent of a for loop. And in this case, you know in advance how many times you want to repeat that activity. The repetition in this case can be in parallel, and then you have 3 vertical bars, or it can be sequential, and then you have 3 horizontal bars. In case of the loop activity, it's always sequential. The difference between the loop and the multi-instance sequential is with the loop that you have some kind of condition to test in order to know whether to stop or repeat once more, whereas with the multi-instance, you know in advance how many times you're going to repeat. So if you look at the examples, in a student help desk, you help students and it's a loop activity. So it means you help the students one by one, and you do this until you have helped the last students that was in a queue. So you can also model that as a little process with help student followed by a gateway where you check whether it was a last student. If it was a last, you stop. If it was not the last, you go back to help student. At the bottom, you see a professor correcting exams. In the first case, there is a course where 60 exams need to be corrected. So it means all these exams will be corrected in parallel. And in the other case, you have 6 exams, and these exams are corrected in sequence. It's further refined on this slide with only 3 exams, because my slide is only limited in space. So you see on the left-hand side, correcting 3 exams in parallel. It's the same as having a parallel split followed by 3 activities. Correct for the first exam, correct the second exam, and correct the third exam. And then a parallel join. When all 3 activities are terminated, the multi-instance activity is terminated as well. On the right hand side, you see the sequence. So it means you first correct exam 1, then exam 2, then exam 3.